Hello friends, we're gonna learn something called averages, mixtures and allegations in Quantitative Aptitude series. Okay, so you very well know about averages, right? We know it from our school days. So what do you mean by average? If you wanna represent some whole quantity by a single number, you just take average of it, right? What do you mean by? So what is the basic formula of average? Average is equals to what? Sum of observations by ratio of sum of observations to the number of observations, right? This is what your average means, right? If you want to represent the whole some numbers, okay, if you want to represent some 20 people, you just, how do you represent? You just take average of them, right? So example, I'm just considering an example, okay? A student appeared for an examination. Let us suppose a student went for an examination, like he took some JNTUH board examinations, like, so in which there are 5 subjects. Okay, let us assume there are 5 subjects, so he's gonna write 5 exams, right? So he wrote the exam and finally he got result, and his marks are like this: 68, 72 and 75, 80 and 85. His marks are like this. Okay, so what are average of these whole marks? Your average is equals to, average marks is equals to 68 plus 72 plus 75 plus 80 plus 85, right? By number of observations, 1 2 3 4 5, right? So 5. So sum of all these, when you add up all these marks, you get 380 by 5. So your average marks is 76. So the 76 is the student's average marks. So there are some points to be observed. There are some properties. There are some important properties you can obtain from these all observations. Okay. So what are those properties? I'm just writing here properties of averages. Okay. These are some properties. What I'm writing here. See, the first property is, see, the out of these all 5 subjects marks, which is the least one? 68, right? The least marks is 68 and the greatest mark is 85. So and what is your average marks? 76, right? So average value always lies between the least and the greatest. And moreover, what you can say is, it is always greater than the least and lesser than the greatest one. See, your average value is always greater than the least and lesser than the greatest one. So what you can write here, average value always lies between the least and the greatest. This is the first property you can write, you can observe. Okay, so and moreover, what you can say from this, it is always average value is always greater than the least and lesser than the greatest, right? You please note it down there. And the second property, see, so he got all these marks, right? 68, 72, 75, 80, 85. So the student was upset with his marks. He was upset with his marks and he was so disappointed with the marks. So what he want to do next? He want to take exam again. So he's going to write exams again, total exams again, supplementary exams, let's say improvement exams, let's say. So after appearing for the improvement examination, after taking the all exams, he got marks like 78, okay, 82, 85, 90, 95. Then his average will be what? See here, 68, previous marks was 68, now it was 78, now it is 78. Previous marks was 72, now it is 82, 75, 85, 80, 90, 85, 95. So in every subject he increased 10 marks, right? So each of the subject marks increased by 10. So what you can say, see, you can observe here, what sum of all these becomes what? 430. If you add up all these subjects, you'll get 430. 430 by number of observations is 1 2 3 4 5, right? So your average will be 86. See here, average is 76 and now here average is, and now here your average mark is 86. So what you can say, if in each and every subject the marks increased by 10, so that average will also increases by 10. So what you can generalize is, if each variable in a group increases by k, the average also increases by k. See here, in each and every subject the marks increased by 10, right? The marks increased by some units called 10, okay, some marks called 10. So the average also increases by 10. See here, 10, 10, 10, 10, 10. So the overall increase is 50, right? So 50 divided by 5, what? 10, right? So average will also increase by 10. So what you can say, if each variable, see, if each variable in a group increases by k, if each variable in a group increases by k, the average also increases by k. This is what I want to say. And you can observe here, see, if each variable is decreased by 10, suppose, see, if and if he again takes the exam and now he gets 10 marks less in every subject, so what the marks become? 50, 58, 70, 62, 65, 70 and 75, right? So what? Overall marks decrease by 50. So what? And even your average decreases by what? 10. So the new average will become what? 66. See here, in each and every subject marks got reduced by 10. 10 marks got reduced in each and every subject. So 58, 62, 65, 70, 85. And when you add up all these marks, you'll get 340. So your average will be what? 340 by 5. And when you cancel this, 340 goes 66 times. 5 into 66 is equals to 340. So new average is 66. So what I can say is, if each and every variable in a group decreases by k, then average also decreases by k. So I hope you understand. And it is also true for subtraction. Not only increases, it also decreases. You can write here. And the third property is, see, okay, it is true for, this property is true for addition and subtraction, right? We proved it. And what about division and what about multiplication? Let's see. So see, the overall marks here is 500, right? 100, 100, 100, 100, 100. So 500. Let us say some. So the overall marks he's writing exams is for 500, right? So let us assume the overall marks now got increased and we need to double these marks. Okay, so 78 into 2. Okay, 78 into 2 is your 156. So 156 plus, and 82 into 2. 82 into 2 is your 164, right? 164 plus 85 into 2 is your 170. 170 plus 90 into 2 is your 180. So 95 into 2 is your 190, right? Oh, sorry, I've considered this case, so I'm just rolling it out. So these are my original marks, right? 68, 72, 75, 80 and 85. So and now overall marks has increased and I need to double these all marks. Okay, so I'm doubling all those. 68 into 2 is your 136. This is your 136. And 72 into 2 is your 144. Sorry, and 75 into 2 is your 150. And 80 into 2 is your 160. 82 is 160, right? And 85 into 2 is your 170. So I want you to add all those. Okay, so when you add all these terms, it appears to be 760. So what is your average? Sum of observations by number of observations. Sum of observations is 760. So 760 by number of observations are 5. So this will be your, it's 152. The original average was 76, right? When you're doubling the observations, the average also got doubled, right? 76 into 2, what? 152. So it is even true. The property is even true for multiplication. So when it is applicable for multiplication, obviously it is also applicable for division. So what you can say is, if each and every variable, if each variable in a group increases by k, then average also increases by k. If each variable in a group decreases by k, the average also decreases by k. So this property is even true for multiplication. We have just proved, right? Here we have multiplied each and every variable with 2, and what we have obtained in the result, as a result, average also got doubled, right? Average also got doubled. See, each and every variable is doubled here, and at the end, average also got doubled. So this property is even applicable for division. Okay, so this is all for this lecture, and in the next lecture we'll solve some example problems. There'll be problems on what simple averages and weighted averages, and we'll cover all the problems based on averages, and we'll also move to mixtures and allegations. Thank you so very much for watching this video, and I hope you got something in this video. You have understood something, you have learned something, and please do not hesitate to share the knowledge, and thank you so very much.